13.4 Factoring trinomials of the form ax squared plus bx plus c. And we're going to use the bottoms up method. Now, up until this point, we have done many factoring procedures. We've done the greatest common factor, factor by grouping, which is the 4 term, and then trinomials where your leading coefficient is 1. So this time, we're going to factor trinomials where our leading coefficient is not 1. It's going to be some other number. And to do this, I teach bottoms up. Now, if you know how to do a different method and you're comfortable with that method, then by all means, please do that method. There's guess check, there's AC, there's box method. Anything that you want to do, that's fine. You don't have to do bottoms up. That's just what I teach. Okay, so factoring by bottoms up. You are going to remember my father drinks Red Bull. There's 5 steps, really and truly 6 if you do the greatest common factor, but there's actually 5 steps to the technique for bottoms up. My father drinks Red Bull. If you can remember that and do the whole entire thing, then you'll be able to factor these. So the first things first, always factor out the greatest common factor. Step number 2, M, multiply. You're going to multiply A times C, your first term, or your first coefficient, times your constant, your last coefficient. And rewrite the trinomial with a leading coefficient of 1, which is what we're used to factoring, for A, and then the product of A times C for C. So now what we have here in step number 2 is a trinomial where the leading coefficient is 1, which is what we're used to doing. So what we're going to do is we're going to factor that new trinomial where the leading coefficient is 1. So then what we have to do is we have to fix what we did in step number 2. So in step number 2, we multiplied that leading coefficient into the problem. Now we have to divide that leading coefficient back out. So whatever you multiplied in step number 2, you have to divide it out in step number 4. So when you do that, you're going to have fractions on your constants. So you're going to divide the constants in each binomial by the original A, leading coefficient, that was multiplied in step number 2. Then you're going to reduce the fractions if you can, and if you cannot, then there's going to be a denominator, and you're going to bring that denominator up in front of the variable in each binomial. So multiply, factor, divide, reduce, bring up. So let's try one. We're going to factor 8x squared minus 14x plus 5. So step number 1, look for a greatest common factor. So let's look at this. We have a trinomial. Our leading coefficient is not 1. So the best option would be to try to factor out an 8 to make that leading coefficient 1. But 8 won't go in 14 and 5, so there is no greatest common factor that we can factor out. Then what we're going to do is we're going to multiply 8 times 5, and rewrite the new trinomial as 8x squared minus 14x plus 40. So notice we took 8 and moved it times 5, and we got the 40, and notice our leading coefficient's 1, that 8 went to the 5 and 40, made 40. Notice the negative 14x stayed the same. Then we're going to factor this new trinomial where the leading coefficient is 1. And remember, we're going to think, what can we multiply together to get 40, but add together to get 14. And that's going to be the negative 10 and the negative 4. And then we're going to divide the constants in each binomial by the original A that was multiplied in step 2. So here is our newly factored trinomial where leading coefficient is 1. But remember, to get here, we had to multiply 8 times 5. So we're going to have to fix that by dividing the 8 back out. So we're going to divide the negative 10 by 8 and the negative 4 by 8. So it's going to look like this. So we'll have x minus 10/8 and then x minus 4/8. Step number 5, reduce any fractions that will reduce. Well, 8 and 10 is divisible by 2, and 4 and 8 is divisible by 4. So we can reduce both of those. So if we reduce 10 and 8 by 2, we get 5/4. And if we reduce 4 and 8 by 4, we get 1/2. And then the name comes from bring the bottom up. So if we have denominators, we're going to bring the denominator up to the front and bring the denominator up to the front. So our end result is going to be 4x minus 5 times 2x minus 1. Alright, let's try again. So for this one, we have a trinomial. Our leading coefficient is not 1. So immediately you think bottoms up. But remember, we got to look to see if there's anything in common. And I see a 2 in common. So I'm going to take that 2 out first. So I'm going to have 2 times 3x squared minus 1x minus 10. And now what I'm going to do is I'm going to start my bottoms up. But when I do that, I'm going to bring that 2. I'm going to just keep chugging it along. So I'm going to take the 3 and I'm going to multiply it times negative 10. So I'm going to have x squared minus x minus 30. And then I'm going to factor my new trinomial. So 2 sets of parentheses. Decide on the signs. They are going to be different. Split that x squared into x, and think, what can I multiply together to get 30, but add together? Signs are different, so we're actually going to subtract to get 1. And I think that's going to be 5 and 6. And remember, your bigger number needs to carry that sign, so that 6 has to be negative and the 5 here. Now, a lot of people stop here, but remember, we have 5 steps. And really and truly 6 because we have the greatest common factor. Well, we've only done to here. So we still need to do divide, reduce, and bring up. So let's divide out the number that we multiplied in. Now we didn't multiply 6 in, we multiplied a 3 in. So that's what we're going to divide out is this 3. So we're going to divide these constants by 3. And then we're going to reduce, if we can. Now this first fraction won't reduce, so we're just going to leave it alone. But this second fraction will reduce to 2. 6 divided by 3 is going to be 2. And then your last step, if there is a denominator, we're going to bring it up front. So you're going to have 3x plus 5 times x minus 2. And we factored that trinomial. Alright, so let's try this one. We have 2x squared plus 9x plus 4. I have a trinomial. My leading coefficient is not 1, but in order to make it 1, I need to factor out a 2, and I can't factor a 2 out of a 9. So I'm going to have to do bottoms up. So step number 1, take the 2 and multiply it times the 4. And so we'll have x squared plus 9x plus 8. Then we're going to factor this new trinomial. Open up 2 sets of parentheses. My signs are going to be plus and plus. Split my x squared into x, and think, what can I multiply together to get 8, but add together to get 9, and I'm thinking 8 and 1. Not finished. My father drinks Red Bull. So I've got to do the divide. So I'm going to divide out the 2 that I initially multiplied in. I'm going to reduce, if I can. And then I'm going to bring any denominator that I have up to the front of the binomial. Now, we have it factored. So one last one. Let's try this one. We have a trinomial. My leading coefficient is not 1. I would like to make it 1 by factoring the greatest common factor of 8, but that's not the greatest common factor. So I can't do that. So I am going to have to do bottoms up. So we're going to multiply 8 times negative 3. So we're going to have x squared plus 10x minus 24. And then I'm going to factor this new trinomial. My signs are going to be different because that second sign's negative. And I'm going to split my x squared into x, and think, what can I multiply together to get 24? And since my signs are different, this time it's what can I subtract to get 10. So multiply together to get 24, but subtract to get 10. And I'm thinking 2 and 12. Bigger number has to carry the sign. This first sign is plus, so my 12 has to be plus. And my 2 is going to be negative. And then I'm going to divide out the number I multiplied in initially. Then I'm going to reduce. 4 will go into 12 and 8. So we're going to have what? 4. Yeah, that's right. 4 will go into 12 3 times, and 4 will go into 8 2 times. And then for my x, it's going to be 2, so I'm going to have 1/4. And then if I have a denominator, I'm going to bring it up to the front. And if I have a denominator, I'm going to bring it up to the front. And now we have it factored.